Technologic, technologic, technologic.
Hello, welcome to another one of our tech series videos. We haven't done this for a little while, so we're back on track, and we've got a nice little exciting little video for you today, and we are going to look around this handrail and spindle detail for a staircase we did with Watershed Architects. We did another video of the whole staircase as a whole, but I wanted to show you this bit. I will pass over to Rob in a minute because this is way above my sort of abilities when it comes to drawing and explaining things, but yeah, I wanted to show you how we went about the handrail, the spindles. It really was quite complex, and yeah, I will introduce you to Rob now. Hello, Robert.
Hello, all right?
Yeah, good mate, good. So Rob did all the technical work on this staircase. This in particular, this handrail in particular at the top is very, very complex. Rob's going to talk us through how he went about drawing it in Inventor, and then what the transition was from drawing it into actually manufacturing it. Rob, if we start with the handrail to start with, and then we'll have a look through the spindles, and then we'll go on to the making of it, if that's all right.
Yeah, fine.
Yeah, so that top bit of the handrail probably, mate, the compound piece.
Yes, so I mean the tricky bit with the handrail, this is quite often the case, is it has to go kind of between two straight sections, kind of seamlessly. And it's not a desperately easy thing to kind of figure out and then also model in 3D. And the reason we wanted to kind of model it in 3D was to then kind of manufacture it, in the way we wanted to. So you have to kind of figure out the best way of kind of getting the curve to look how you want it to look. And obviously we had the curve that we wanted the handrail to follow. But obviously that's only kind of in one dimension. So you also have to think about how the handrail needs to fall, which you can kind of see here more clearly. So kind of to do that, that you use certain kind of calculations and certain kind of things to figure it out. So I mean the way.
Rob, just while we're doing it, if you can sort of explain, just for the really nerdy people, like what was the techniques you used within Inventor to do this?
Okay, yeah. I mean, so to create the kind of the compound curve between the two straight sections, I just used a 3D sketch and kind of used the radius that we had to follow as a means of constraining it, and then also I used kind of a fixed increment that I felt would work for this particular kind of size of curve section to kind of work out the drop. You quite often start by doing it, you're kind of using a calculation, so these all started kind of equal, but when you do that quite often it then doesn't actually look right, so then you kind of go through this process of manually tweaking these dimensions to kind of make the drop look as good as it possibly can. And quite often that's a manual process as opposed to using a calculation.
Yeah.
And once
I'm saying yes as if I know what you're talking about here, but
yeah,
carry on.
I mean, essentially you work on it kind of as it is here until you're kind of happy with how that curve looks in kind of all directions. Quite often you'll get it looking really nice from this view, and then you'll kind of come to here and you go, oh, actually it doesn't work from the other side. So you kind of work at it until it looks as good as it can look. Once I had that curve mapped, it was fairly simple in terms of modelling to create the 3D model.
Yeah, it looks it.
Once you've got the positions, you can then create a series of planes that kind of follow the curve. And then what you have to do is you have to create or sketch the profile of the handrail on each one of these planes. Essentially, you're creating a series of kind of views that you can then knit together
Join
to
up.
form this 3D model. The best way of seeing it is if I go into this, you can kind of see how it does it.
Nice.
So it's used all of those sketches that I've created in section, and also used the curve that I kind of created to form this profile. And then once you've formed it in 3D, you quite often have to go back again and kind of play with it until it kind of looks good, in every way.
That's nuts, mate. Brilliant. Maybe if we could just have a look how the spindles like intersect underneath as well, because this is the bit obviously that we sent a way to be 5-axised out.
Yeah, so to make sure they knew what they had to do, I then had to kind of map where the spindles were going to hit the handrail section and essentially do that cut. So then they knew and they could machine, based upon our 3D model, where those spindles were going to go.
Yeah. And I must say, when that come back, it was absolutely perfect to this model.
It was absolutely, yeah.
It was unbelievable.
It was identical, yeah. No, it was really good.
Have you got just while we're looking at that bit of the handrail, have you got the drawing just that we sent to the 5-axis CNC company? Obviously we just sent them our model, didn't we? And they literally CNC'd it from our model.
Yeah, so we sent them a very basic drawing, which just kind of outlines the number of components that they needed to manufacture.
Yeah.
One thing I would say is we had to kind of do additional work to the components for them to then CNC it. You know, we had to kind of add fixing holes, you know, which kind of all happened later at kind of the production stage.
Yeah.
To make sure when we put it all together, obviously it all fitted together. One of the kind of key things that I wanted to make sure I could explain to the people that made the handrail was how the timber, you know, was to be machined.
Mm-hmm.
You know, I didn't want them just machining it all out of a block, because once machined it would potentially move a lot and you'd have issues, you know, with it staying in the right place. So I just used this drawing here to kind of explain how the components needed to be got out of, you know,
a piece of
the
wood.
solid timber. Exactly, yeah. And also to give them the sizes of the blanks that they would need to produce to do it.
Brilliant, mate.
Yeah.
That's quality. Can we have a look at the spindles a minute? So the spindles on this are, they were all steam bent individually, actually. We made up formers and stuff, steam bent them, and then clamped them while they dried for like a month. But can you just show us, this is something that blew my mind a bit, when you were actually drawing these spindles and the shapes, how you went about drawing them in this model?
So to get them to look kind of right and I think kind of proportional and kind of equal, essentially just used a series of kind of equations, or a series of values, and then kind of some basic equations to make sure that the top and bottom sections were curving the same. Mm-hmm. Obviously on the straighter sections this was quite simple. You can see the kind of numbers involved. There's nothing too complicated within that.
Yeah.
And then once you kind of had one that you were happy with, it was a case of just essentially just creating a pattern of those. It became trickier when obviously again we had to turn around the corner.
Yeah.
So using kind of a similar formula, each one of these spindles is unique because each one is dropping, as you can see here.
Yeah.
And then when you get to this section here, it became more complicated because you're now on the slope of the handrail as opposed to a straight section. So this is probably the more complex part of it, but it's the same equation, but just using the drop of the stairs to kind of calculate how the two different spindles would look.
Yeah, because the left and right one are obviously slightly different there.
Yeah, exactly.
As it went down the stair.
Yeah, so again, using the same equation, I kind of made sure they looked correct, and they did. And then again, it's just a case of patterning that down. And the whole aim of this was to kind of try and limit the amount of variables. So in the end, we only had kind of 4 different sizes of spindles that we needed to make.
Yeah.
Trying to avoid having too many kind of unique components that would have made it a lot more time consuming to make.
Brilliant, mate. That's it, I think, mate. I just thanks for that. It was just more to show the level of complexity of this staircase. We've had all the photos and that have been done now, and it's being shared around, and it looks simple and elegant, and but it really wasn't that easy to bring to life. So yeah, nice work, Rob. Thank you for that, mate. And